Hello, this is a video about how we might decode some JSON. So I'm going to use this website, which is regress.in, and use this list users endpoint, which we can see gives us some JSON there. So in order to decode this, you might want to look at that JSON in detail, and I don't like that small window. So we might go here, and we have the JSON written out. And I've actually already copied and pasted this, the JSON parser online, and I can kind of see the structure of the data. So that's going to be useful in order to decode it in Swift. So if I go along to Xcode, I can start up a new project. Now this project's going to use plain Swift. It's going to be an iOS app. What could I call it? Decode Json. Seems reasonable. It's just going to be Swift, nothing special there. And just put it into my folder. So the first thing I might do is set up this project because I'm going to create it without using the storyboard. So that involves deleting the storyboard, move it to the trash. And there's a couple of references here to main. And main, and there's a reference along here. And then there's some code. Okay, we're going to keep the Xcode version. There's some code which goes in the scene delegate, which tells Xcode which particular window we're opening. So I just replace that function. And then we're going to have our view controller. And that's fine. I've already set up this code for my view model and my view controller, so I wouldn't expect that necessarily to compile yet. So I'm going to have a view controller, and in that view controller, I'm going to load a view. So the first function that's going to run here will be load view. And I'll have a view. And I want to see it, so I'm going to make the background color be red. Okay, that looks fine. Now I'm going to use a view model with this. So when we initialize, we're going to create a view model. So I'm going to need a file for that view model. Okay, it's going to be a class, so it can be used multiple times in the application if needed. View model is not the best name for it, but at least it's a name. So then we can reference that in our initializer here. It doesn't equal view model, it's a type view model. It's going to be the view model from the initializer. And we need a required initializer. I'm not going to make this work with the storyboard, I'm just going to make it work with code. Okay, we need to call super. I'm not using a nib, so there's no nib and there's no bundle. This may or may not work with a simple red background. Okay, so we've got something up and running. So this is just a project running without the storyboard that shows us a red background. And what I actually want to do is start decoding JSON. In order to do so, I'm going to need a model. Now, I pretty much already know how this looks because I have the code here. And this is going to be users. Yeah, it's list users. So I'm going to call my model users. To make sure that this works, I'm going to create a value type, which is a struct, because then when I copy it around the app, I've got understandable behavior, struct. Now, how do I decode this? Well, the first is a page, which looks like a number to me. Can you have half a page? No, so it's going to be an integer. Like that. Now, per page, as we can see there, let's make it a bit larger. This is also likely to be an integer because it's a number, but per page uses an underscore here, and JSON often has underscores. And we tend not to use it. There's various style guides around which advise you to use camel case. Now, when we pull in that JSON, it's not going to automatically change here. We can set up our decoder to do that work for us. So I already know this is going to work because every time it has an underscore, it's going to replace it with nothing and put the next letter as a capital letter, but only if you set up your decoder properly, which obviously we haven't done yet in the order that I'm doing this. So total is an integer, total pages looks like an integer, but again it's got the underscore. So we get rid of the space and make the next word a capital. It's going to be an integer. Now this data is an array. So it's important that data has the same name. The only reason we change the names for this particular struct is where it has the underscore, because we don't use camel case. All the others should be exactly the same. And data is going to be an array. An array of what kind of data? I'm going to call this user data, which hasn't been defined yet. And we have another one, which is support, and this just has 2 strings inside. And I'll call that a type of support. Users does not conform to protocol decodable. That's fine. We're only conforming to codable to enable us to decode this using the JSON decoder. And as we go through, eventually this is going to conform to the protocol. So cannot find user data? No, we can't. So we need to set up a struct for this. So I'm just going to set up another struct. I could nest it within this struct, but just for ease of reading, I'm going to do it here. So what do we have here? We have an ID, an email, first name, last name, avatar. This is a string, it's green in this particular parser, and it has the quotation marks, so it's a string. Even though it's, looks like a URL, it will be passed as a string. Email the same, it's just a string, and this ID is going to actually be an integer. So, as we said, email string. Now, first name is a string, but again, instead of using this underscore, we're going to use camel case. Last name is a string. That avatar, I need to make sure I spell avatar properly, if not this isn't going to work. And the last part is going to be support. Struct support. Now all of these need to conform to codable, because if one conforms to codable, they all do, because this references user data. So if this is codable, this should be codable, so support should be codable. If I build the project, there's a chance that this succeeds. Okay, so this is my struct, which I'm going to decode the data into. And what I need to do is actually download the data. So in my project, the view model is probably the best place to do that. So a view model should communicate with the view controller. The view controller knows about the view model because it instantiates it, but the view model doesn't know about the view controller. So how can we pass the data back? Well, best way in Swift, I think, is a completion handler. So what we're going to do is let our view controller give our view model a completion handler and say fill in this data. And this data is going to be the user's struct and not return anything from that handler. And then we're going to have a function to download the files, which is where we're going to use our URL session. Now, we need to set up a URL. URLs are always painful because a URL with a string parameter there returns an optional URL. Now, one way to get a URL is to put a false unwrap. False unwraps are bad. False unwraps will get you fired from your job. So in this instance, I'm going to use a guard. The guard statement means an early return, so it will return here if the URL can't be calculated. So what is this? This is the last part of the URL, but look, I've hit it here, so I can just copy and paste my URL. And in Swift, what we have is a task. So this session task is going to be URL session shared data task. And there's these various initializers, and what we need is to give it a URL and get the data and response back, which looks a lot like this one. There's always a problem with the task in that it will do nothing until you task.resume. So now I need to fill in these placeholders. So we're going to take the URL, and we'll have a completion handler. So I use the curly brackets, and if I build at this point, it's going to tell me I need 3 arguments. And it's never very helpful, it doesn't tell you exactly what they are. Yes, they're there when I press Option and Data Task, and you have URL, data, URL response, and error. So I can more easily call them data response. And now error I'm not going to use in this particular project, so I can leave it as the underscore. Now what's going to happen is we're going to decode this data, and then we're going to hit the completion handler. Now the completion handler will need to be referenced as self completion handler, which means we set up a reference to the completion handler. If the network never returns, there'll always be a connection between the view model and the completion handler, meaning that there'd be a reference cycle. So to remove any possibility of reference cycle, we add weak self there. Okay, so when this returns, we're going to get data returned, and data itself is optional. So, let me just confirm. Data is optional. Your URL response is optional. So again, if we don't have that data, for some reason we're getting nothing back, we would want to return nothing. So we can make sure with a guard statement that we have some data. In fact, we can make sure our response is something. And even our URL response, we can make sure it's in the known values for a good response, 2 to 300. If not, we return. Now this has got a little bit tricky to read, so I might put the lets on separate lines, and I'll prefer the else there. So it's just a little bit easier than a very long string of text. Now we need to set up our decoder to do the work. And this is where we've got that decoder strategy. So we can tell that we want our keys to change and that we're converting them from state case, which is the part which is going to make these like total pages work from total underscore pages. Looks like our indentation's off. Control I will sort that out after selecting if let decoded. Now, this is a try, so using a forced try will possibly crash the application if we can't decode. Using a question mark means it will return nil if it doesn't work, which sounds fine in this particular project. Users.self, so that is our object, which is users, which we set up here. So that's what we're going to decode from data. And data, because of the guard here, is unwrapped, so we don't have to unwrap it there. So if we manage to get the decoded data, self, which is optional because of weak self, completion, which itself is optional, we don't have to have a completion handler for this to run, decoded. Okay, so we can build, but the fatal error at the moment is nothing happens, because when we run the project, we don't have any call to this, and what's worse is we don't display anything to a user. So we're going to do just that. So to display this to the user, I'm going to create a lazy var. If I could spell lazy. So in the beginning, it's going to be a text view without a frame, so we won't see anything going on. And what we're going to do is set up some functions to make this easier to read. So it's going to be a setup hierarchy, setup components, and setup constraints, because we're going to have to deal with our auto layout constraints ourselves. So of course we need to set up those functions. So this is going to add our subview. And before we do the constraints, I'm going to say I'm going to take care of them. It's one of those things that often causes problems and unexpected behavior. So I've used translates auto resizing mask into constraints because I'm going to take care of those constraints. Okay, and I'm just going to put the text in the center. So what does setup components look like? In fact, this is wrong. Setup hierarchy is adding the subview, but set the alignment sounds like it's a component thing. So we put the component, we put the setting the property in setup components. And I'm going to stop the user from copying, pasting, moving the text. And just in case something goes wrong, I want to see what the text is. So that would be placeholder text. And of course we need some constraints to be set up. So this is an array of constraints. We'll need one for the top. And it's an array, so we need commas in between these. Instead of typing everything out, I can press tab. It makes it slightly faster, but I always find it's more error prone as well. Start trailing. So top bottom is the top bottom of screen, leading's the left hand side on a usual left to right text basis. So these were introduced instead of left and right to make that clear. It's just good practice, I believe, to use trailing and leading as per course. So this will work. This will set up our constraints. Now if we run, we're expecting this. If I spell, oh, nice spelling. It's probably a good case for why to write the function before you try and call it. So this is our placeholder because of course we're not calling the URL yet. So I'm going to choose to do that in view did appear. So it will be visible to the user that it's loading. And I happen to be happy with that behavior for this project. View did appear, animated, so we're calling super. It's always good practice. Now we need to set up that completion handler. In the view model, we have the optional completion handler. Here we're going to say what to do when that completion handler is called. So it's going to be a closure. And we happen to know that this closure is going to accept one parameter, which is going to be our users. So we know we want to display our text, so we can do text.text equals. But what? We could have users.data. So this is our data. So we could take the first data and the first email and the first name. Now I know that this is going to cause a problem. Because the completion handler is being called, this warning is telling us to be careful. And because this is being called from the network, so on view model, we're going around the network and on the background thread, and we come back here in the completion handler, and we're going to expect an error that says you're trying to update on the wrong thread. Except, of course, I haven't told it to download the file. So I set up the completion handler first. If you try to call download files before you've set up the completion handler, it's nowhere to send the data, so it won't work. And here we've got the expected error that it was called on the wrong thread. Let's look at that error. Must be used from the main thread only, which is actually quite trivial to solve. So that says, put this data onto the main thread. So then you can update the text view. And it says Michael. It's not very satisfactory. And lots of people will say, actually, you can make this better anyway. Instead of saying users, which may or may not be a helpful name for that parameter, you can use $0. $0 means the first parameter. Interesting, doesn't accept closure, so we can say let text equals and it should come up the same. What did it say before, Michael? But that's not very satisfactory. I want it to display multiple names and emails. So what we do is we take data and we can use a mapping function. And then we can use a trailing closure syntax. I prefer to use string interpolation for this instead of saying plus string. You can say I want to put parameters in there. So we'll take our users, first name. So it's a map for each of the users, and this dollar syntax means each of our user. So this will be Michael in the first instance. And he'll have a last name, whatever that might be, and then have an email. Of course, I'm mapping it, but it's still an array of strings. So what I want to do is join it back to be a string, and I'll use a \n, which is the next line. So I'm expecting a number of lines, probably 1, 2, 3, 4, 5 lines, each with different names and emails on them. 1, 2, 3, 4, 5, 6. Someone can't count because Michael's on a different line there. So this is a very basic idea of how we might decode some JSON using Swift. And this is a very common thing, and people often say programming for iOS is just taking JSON from backend and displaying it on the screen. So this is an example of how you might do that and some of the skills you might use to do that. Hope this has been in some way useful to you. So thank you.